In this video, I'm going to walk through a heat transfer problem. So if we read this problem, we can see that there is some metal that is hot and it is dropped into water that is colder. And so based on the fact that we have two substances, one is hot, one is cold, that's how we know that we have a heat transfer problem on hand. And there's going to be a lot of information here. So the first thing we'll do is write down, make a table with all the different variables. So there's Q, we have also M, we have C, and we have delta T. And we have these for two different substances. We've got water, and we also have this unknown metal, which I'm going to call capital M. So the specific heat of the metal is what we don't know. So I'm going to put a question mark here. The specific heat of water is not given, but you may have it memorized by now. It's 4.18 joules per gram degree Kelvin. For the sake of spacing, well, let's see. There we go, joules per gram degree Celsius. All right, so our mass of water is 200.0 grams. And our mass of metal is 100.0 grams. The change in temperature, well, the water is starting at 10 and it rises to 30. So our temperature final is 30 degrees minus our temperature initial is 10 degrees. That gives us 20 degrees Celsius. That is the change for the water. In the case of the metal, it gives us an initial temperature, which is 100 degrees, 100. And the final temperature, though, is not given to us. However, if the water rises to 30, we know that the metal must meet it also at 30 degrees because they reach thermal equilibrium. So the final temperature of the metal and water must be the same. So 30 minus 100 gives us negative 70 degrees Celsius as the temperature change for the metal. So what's missing here? Well, we don't have Q for the water, we don't have Q for the metal, and we don't have the specific heat of the metal, which is ultimately the last thing that we'll find. Now, we are going to assume that any heat that is gained by the water is the same as the heat that is lost by the metal. So actually, what we can do is solve Q equals mc delta T for the water, and then use that to get to the metal. So let's start with the water. The Q for the water is equal to, we have 200 grams times the specific heat, times 4.18 times the change in temperature, which is 20 degrees Celsius. And that's going to give us 16,720 joules. There we go. So that's our Q. And that's our Q for the water. Again, this is important. This is for the water. This is what the water is gaining. Now, we can solve a separate Q equals mc delta T. This is our H2O here. And this is going to be for the metal. So I'm going to put the M down here. We know that Q equals mc delta T. And we know that the Q that is gained by the water is the Q that is lost by the metal. So I'm going to say negative 16,720 joules is our Q for the metal. In fact, I'm actually just going to put that here just so that the table is complete. So our negative 16,720 joules for the metal, And I'm going to have positive 16,720 joules. Whoops. 720 joules for the water. All right, there we go. So anyway, back to here, our metal is losing 16,720 joules, and that's equal to the mass of the metal, which is 100 grams. 100.0 grams times the specific heat, which we don't know, times the change in temperature, which we know to be negative 70 degrees Celsius. So what we can do from here is simplify a little bit. Our negative 70 can be combined with our 100, and so that becomes negative 7,000. So we end up with negative 7,000 times C on the right side is still equal to our negative 16,720. And because we're trying to get our C on its own, and it's been multiplied by 7,000, to undo multiplication, we need to divide. So what I'm going to do here is I'm going to divide by negative 7,000 on the right side, and that cancels out the negative 7,000 to leave C on its own. But if I do that on the right side, I need to also do it on the left side. And what we end up with is, again, C is on its own on the right side. So our C is equal to, I'm going to say 2.4 joules per gram degree Celsius. And that is how you solve a heat transfer problem. Hope this has helped. Feel free to leave any questions or comments in the comment section below. Thank you.